a cubed. What do you get? A to the what's it telling us to do?
A to the fifth.
A to the fifth. If I got two exponents and I'm multiplying right there, I'm really just adding them up if they have the same base. So it's really a to the 2 plus 3. So this is really a to the fifth. Now we go ahead and we look at this one. So if I'm doing division, I'm subtracting. Now I won't lie to you, I don't always like to think of it like that. How I picture it in my brain is I actually think of like if I have 5 b's, if I have b to the fifth, right? I have b times b times b times b 5 times. So I would just say I have 5 up top, and I have 3 on the bottom, and we cancel them out. So if I cancel them out, 3 of them disappear. How many are left? Just 2. So that's how I visualize it when I'm doing a problem like this. But it is subtracting. So I get b to the 5 minus 3, which is b squared. Letter C is power to a power. So now we get y to the 6. Yeah, thank you. Any questions so far? All right, negatives, I want you to actually add to letter D. I not only want you to have 1 over g to the negative 4, I also want you to have, we'll go with w. I want you to have w to the negative 3 and put an equal sign. And we're going to explore what happens to both of them. So if I have 1 over g to the negative 4, we don't like negatives. We never accept a negative exponent in a solution, typically. So what I'm going to do is I'm going to make it positive. And to make it positive, you just flip it. So this becomes g to the 4th over 1. Now, I say over 1 because every single thing here is over 1. But the 1 actually truly isn't getting flipped. It's just sometimes easier to see. So I'll just put g to the 4th. When I look at this one, if I want to make it positive, I flip it. So I take it from numerator to denominator, and I do whatever the opposite is. So I'm going to have 1 over w to the 3rd. So that's how we deal with negatives. You just put it where it's not. Okay, that's all the negative is saying. It's saying, I don't belong here, move me. So that's our exponents. When we look at letter E, what exponent does 2 have? 1. Now, that is the most forgotten thing. People see it as 2x squared, and they're like, that is 1 piece. And that's not. It's 2 pieces. It's a 2 and it's an x. They are separate. They are put together because we're multiplying them. But there are 2 pieces. So when I go through this problem, I'm going to take the 3 and multiply it by 1 and 3 times 2. So I'm going to get 2 to the 3rd times x to the 6th. Now, 2 to the 3rd is something that we can calculate. I think that's reasonable. So I would want you to calculate that. I would take this as 8 x to the 6th. And that would be my solution. What's this last one going to do? You've done this before. What happens? Yeah, you have to distribute. So we're going to write this like this. 2x minus 3 times 2x minus 3. I'll give you about a minute to do that. What do we get when we multiply these things out? Let's just go to the answer. What's the solution here? What's the simplified or the changed form? Well, I'll start. It's going to be 4x squared. I'm And what do you get? Last piece. Plus 9. All right. And, you know, distributing the 4x squared is easy to see. That's the first two pieces. The middle pieces are normally the harder part. So the first and the last are normally the easy pieces, just like when we factor. That's why we start there, because it helps build for us. But then you can do a quick check. So you're just looking at a 6x and a 6x. And in this case, both of them would be negatives. So that's perfect. Very nice job. Questions? Flip that page when you're ready. All right, 3 to the 4th. We're going to simplify. What's 3 to the 4th? What? 81? Yeah, it's 81. When you look at number 2, the first thing I do whenever I see a negative exponent is get rid of it. So that negative exponent doesn't belong right there. Where does it belong? Yeah, down below in the denominator. So I'm going to write this as 1 over 5 squared, which is the same as 1 over 25. Now 3, I know the answer says to simplify, but we're going to just write it in a different way. We're going to change how it looks. So instead of writing 1 over 343, what could I write that as?
1 over 7.
7 to the what? To the 3rd. So that'd be a different way of writing that. So now we're going to run through a few of these. And then when we get towards the bottom ones, then I'll start letting you do more of them. So when I look at number 4, I think of how do I break this up? And I always break them up in terms of this. I look at the numbers first. And I'm just talking about the integers or decimals or whatever I'm given there, but just the numbers that are sitting out in front. And so I will always simplify before I do anything with what's out there. So let's simplify that. 21 divided by 14. What is that? It's a fraction that reduces. 21 divided by 14. What? 3 halves is perfect. So I can divide both of them by 7, and so when I do that, I get 3 over 2. You could always type that in your calculator and use the fraction key. I know, we don't have calculators right now. That was kind of neat. But you could in a pinch if you needed to. I talk about my x's. I have x squared and x cubed. How many x's do I have and where?
You have a lot of answers.
We kind of do have a lot of x's, but when we simplify them, how many x's do we have?
1.
We have 1x, right? 2 minus 3. But where's that x going to go?
Bottom.
On the bottom. Yeah. So I have more x's on the bottom than I do on the top. That's why I caution you with this. When I go like this, it only becomes x minus with the 2 minus 3 up here because I'm actually truly taking that x and putting it up top, making it a negative. So then when I get an answer of x, wow, minus 1, that's actually telling me to go back to the bottom. Now, that's why I like to think about where do I have more. I have more in the bottom, so I'm going to put my answer in the bottom. So I got just 1 down there. How many y's am I going to have? 4. So I have 1 up here, 5 on the bottom, so I will have y to the 4th on the bottom. And so that's squared. So now we square everything. So 3 squared gives me 9. Nothing else on the top. Top's done. Go to the bottom. 2 squared gives me 4. What's x squared going to be? X squared. Yeah. What about y to the 4th? What's that going to become? 8. because we have our exponent as 4 times 2. So power to a power translates to multiplying. So that's what we get. So we get an 8 right here. Can I reduce the 9 and the 4? No. That's our final answer. If we take a look at 5, I'm going to reduce right away. 2 divided by 8. What is that going to become? 1/4. Now, let's think about this. So I got 1/4. X to the negative 3, I'm going to tackle that right away. Where's it going? To the top, so it becomes positive 3. If you're moving it, it has to change the sign. So I'm here. Now, if I'm writing this, I'm actually really going to ignore this 1, because what's 1 times x cubed? Just x cubed. So it doesn't necessarily go away, but simplified down, it's not really needed. So now I multiply, and I'm going to get x to the what?
6.
Let's vote. What is it? Power to a power. Adding or multiplying? Multiplying. So it is going to be 9. What is 4 to the third power? Because remember, there's a 1 right there. So this is 4, the first times 3, which this is going to be 4 to the third. And 4 to the third is what number? You already have this down.
64.
64. You're good. So we get 64. Done. Questions? We're going to skip 6. Cross it off if you want, or leave it, doesn't matter. We are going to jump straight to number 9. And so when you look at number 9, there's that negative 3 on the outside. And so it's telling me that I flip everything on the inside. So I want to get rid of that negative, and so I'm going to change how I write that simply to be x cubed and 2, and this is going to be to the third. So negatives, again, flip. So that negative was to the whole thing, so it would have made this a negative 1, so I flip it down. It would have made this a negative 3, so I flipped it up. So that's a step you can always do when that's what you got. So let's just talk about it. So I'm going to have x to the 9th, just like I did on number 5. We have the same thing there, power to a power. This is going to be 2 to the first raised to the third power, which gives me, what? 8. Yeah. It is going to be 2 to the third, which does give you 8. So I am going to jump to 8 this time and leave that there. I want you to try 10, 11, 12, and that's it. Those bottom 3. Give you some time to try those out. Those are not done, by the way. They are just like what the first step could be. Doesn't have to be what the first step is. It's what the first step could be. So if I'm looking at 10, I got rid of my negatives, first thing I did. Then I'm going to have this, which goes to 1/3. So I'm going to put 3 down here. If you put 1 up here, I'm not going to penalize you for that. I would not in my final answer. But you could. And I actually lied. This time you need it because how many x's are up here? None. There's going to be 4 x's down below though. And so we do get 1/3 times x to the 4th times y cubed. So again, just think about your numbers. If I have 5 x's there and I have 9 below, where's more x's? There's always going to be more down in the bottom, in the denominator. So that would be number 10. Number 11, this is one of the first times you have dealt with a number that is placed there with a negative exponent. So we just drop that down, and it's not really that bad because 8 times 3 just gives you what? 24. There's no other numbers that I have to deal with that are the base. So I got 24. Now let's talk about the rest. How many y's am I going to deal with? Because I only have 1 of them. So does anything change? No. So I'm going to just put y. And I don't have to put to the first power. What about the x's? More on top. So how many x's am I going to have on top? How many? 5. 5 is perfect. So I got 5 right there. And just to remind you, there's that 1 right there. So I'm really going 6, taking away the 1 and giving me that 5. So that's 11. Whoa, cut through that one. Last one. So you notice that this one gets a little tricky. I deal with the negative inside first. I am going to simplify. When I simplify, I get 5 over x to the 5th. And then I have to deal with that negative on the outside. So I flip it. Could you do that from here and just skip this? Yes, you could. But when you flip it, it's just going to be x to the 5th divided by 5 to the 3rd power. So I cube everything. How many x's do I end up with? X to the what? 8 or 15? 15, good. And then on the bottom here, x to the 3rd is what? 125. So that gets tricky because of this. Sometimes we're multiplying, sometimes you're raising it to a power. But realize that's just really 5 to the 1 times 3, and then that's what happens. So, questions, what do we got? Yes?
So are we only using like a negative solution here?
Yes. Like, you're talking...
You don't move the whole thing to the
No, and that's a common thought. So like here, I will see people take this and go, well, you know what? We're going to change that, and I'll come this way. and they make it this. Well, what's that exponent on x? 1, and that's a positive exponent. So if I move that, that would actually make this a negative exponent. That's not what we want. So move only individual pieces, okay? Every item has its own exponent, even if it's not explicitly written. So just watch out for that. Questions? You got about 5 minutes. I do want you to get started on your packet. So this packet, I'm going to really be hounding